Happy Monday. I'm Jay Fidell. This is ThinkTech Talks, and we are talking about the SOWEST Hour today, the School of Ocean and Earth Science and Technology. And the subject of our show is VOG measurement and prediction, which is really important in Hawaii. And our special guests are Stephen Businger, who's a professor. Did I get that right?
Close enough.
Okay. Who's a professor at SOWEST, and Andre Pattantyus, who is a PhD candidate, a graduate student at SOWEST. Thank you for joining us, gentlemen.
Thanks for having us.
Our pleasure.
So, qu'est-ce que c'est this thing, VOG? What is it?
It is an emission from the volcano on the Big Island, Kilauea in particular, and it's comprised of carbon dioxide, water vapor, sulfur dioxide, and trace metals and gases.
How does it get created?
Well, it is an outgassing from the lava when it first reaches the surface, and the pressure is reduced on the lava, and it allows the dissolved gases to come out. Kind of like when you open a beer can and you hear a bit of a fizz, or a Coke can. It's that kind of a degassing of the lava.
So, if I go to Kilauea, I forget the name of that big vent right there as you walk. It's sort of a lake, and you look down on it from the volcano house, and I see plumes of smoke coming out. Is that VOG?
That is those are the emissions as they're coming out. So that's what you're primarily seeing is water vapor and SO2 and carbon dioxide.
Okay.
So, yeah.
And when I smell it and it gets caustic in my nose, that's VOG.
Yeah, that's the sulfur that you're smelling. Yeah.
So if you put me in a room full of VOG for any length of time, I'd be an unhappy camper.
Very.
Yeah.
Yeah.
What would it do to me? I mean, biologically.
The SO2 gets reacts with water, so when you breathe it in, it gets caught in your upper respiratory system, and so it'll start causing upper respiratory distress. And then if there's a lot of chemical reactions going on in the air that you're breathing, then it can turn into particles, small particles, and then that'll go further down your throat. And eventually, you keep on breathing it in, your distress will just keep on going up until you're...
So it's essentially an acid
in
my body?
It reacts to the point where it turns into an acid, yeah.
It oxidizes to sulfuric acid.
Yeah.
That's not a happy thought at all.
No, that's why people get itchy eyes and sore throats from VOG when it's over Oahu.
So now there are groups that are more exposed than other groups, right? If you're elderly, for example, if you have respiratory ailments to start with, it will have a more profound effect on you, yeah?
Yeah, it exacerbates those. So a study came out last year that kind of covered those, and so people over 50 were most affected. And then if you had cardiorespiratory problems, then it's just really bad, so you need to pay attention to advisories and not expose yourself to that.
Did it kill you?
No, but it'll send you to the emergency room if you're...
Because you can't breathe.
Sure, yeah.
People get asthma attacks, and
sure.
it seems that the people who are allergic to pollens and those kinds of things, they tend to have allergic reactions. They're more susceptible to having a bad reaction to VOG.
Now, VOG is a sort of a play off the word fog, I guess.
Smog,
Smog,
actually.
yeah.
It's
Okay,
volcanic smog.
Yeah.
Okay, volcanic smog. Okay. And I'd like to explore with you later, how what we learn about VOG can help us with smog, or fog, or whatever it may be.
Yeah.
But mostly, VOG is unique to Hawaii, right? And you have to have a volcano to have VOG.
Right. Yeah. There are other volcanoes around that produce VOG. So, but Hawaii has one of the most active volcanoes. It's been running since 1983 continuously.
So SOWEST is interested in such things because it is the School of Ocean and Earth Science and Technology, and anything that happens on the Earth, especially things like volcanic action, are the business of SOWEST. And so you guys like to research and explore and find what's going on about those things, including especially things like VOG.
That's correct, but VOG is particular in that it has such a strong, profound impact on society. And so we also saw a need to investigate it and to try to model it and provide a product for society so that people can go online and see where the fog plume's going, and if they are susceptible, if they're elderly, if they have propensity for asthma, that they can, plan their outings.
So what sciences come into play when you're addressing this question?
Well,
everything.
First you have to measure how much sulfur dioxide is coming out of the vent, and then you need to know what the winds are doing and how the winds are going to distribute or disperse the fog coming out of the vent. And so it's kind of a combination. It's two different models that are used in order to look at the fog prediction. One is a weather model, which gives you the winds and the stability and the clouds and so forth. That's a very high resolution weather model. And then we take the output from that and put it into a dispersion model and see how the pollution is dispersed in the lower atmosphere.
Okay, so first you have to know about volcanoes. You have to be a volcanist?
Well, we work with volcanists. So what I would say is that this is a multidisciplinary
Yes.
endeavor.
I know Don Thomas.
Yeah, from CSIC.
He's a volcanist.
He's a volcanist.
And he's been on the Big Island with volcanoes for a long time.
Yes.
Is he in this project? Does he do things around this issue?
That's a good question. I would say that he does, although he's not so involved with the atmospheric part. He's more dealing with the lava part.
Yes. So that is different.
Yeah.
The lava stays there, and the atmospheric, elements go there. Okay, so then if you're talking about a weather model, you need to know a lot about weather. You have to anticipate weather. You're the weatherman plus.
Right.
And you're using what the weatherman has, but you're trying to apply the weather to something else which is moving. So you got two dynamic systems working at the same time. This is complicated. Yeah.
The weather model it involves taking all of the satellite data we can get and the ship data and the surface observations and interpolating that into a model grid that you can then apply our known equations of, for example, force equals mass times acceleration to move the wind, and that's how the weather model works.
This is sounding more and more like fun. Now, just to distinguish that, the weather model with the dispersion model, dispersion is a whole other system. Dispersion, what's the properties of these gases and whatever comes out in the fog, the properties of how they move around physically in the atmosphere.
Right. It's taking the winds and looking at the influence of turbulence in the air, those chaotic motions on very small scales, and statistically distributing the pollution with known sort of understanding about the turbulence. And the turbulence comes out of the weather model too, and so you get some help with regard to this dispersion. But that's Andre's job is to run the dispersion model.
So before we go to Andre on this, are you teaching this? This is something that you're teaching, Stephen, or is this something you're researching, or both?
I would say both.
Must be interesting. And your students, are they exclusively from SOWEST? Are they exclusively graduate students? What's the pattern of students in your classes?
Well, we have undergraduate classes right down to introductory 101 classes where we try to get the lay people, the art students, excited about science. And then we teach meteorology classes to undergraduates, weather and forecasting. And then we have graduate program as well. And so I teach a range of undergraduate classes, and then I have graduate students that work with me on research.
If I were coming around, I would want to take a class in VOG because it's multidisciplinary, because it has lots of interesting things, not just one. It would teach me meteorology plus.
You're welcome to sit in.
Thank you. Is it my age or my interest or both?
Well, I think interest is something that we like to encourage in any case.
Well, I think people in Hawaii should be particularly sensitive and interested in SOEST. We're an island state. We have to be conscious of our island and our ocean and earth. And we really need to study this. We all have to have a consciousness about it. So I'm happy that you're here, and I'm happy that SOEST is doing what it does. And I think it's a high point. One of the best things about Hawaii, right?
Thank you very much.
So anyway, let's talk about your work.
Sure.
If you're a PhD candidate, it means you're working on a dissertation.
I am.
Does dissertation have anything to do with VOG?
It has everything to do with
Okay.
VOG. Yeah, so I work on the VOG model that we run at UH on a regular basis, and so I'm continually trying to upgrade the model. We're looking at the way that we start the model, and then I'm working on the chemistry as well. So I already mentioned that the SO2 can turn into tiny particles that can get into your throat, and so this is a big thing that I'm working on for my dissertation, is to add that kind of complex chemistry in there, because SO2 is bad for you, but the particles are worse, and so we can get, that's the primary contributor to VOG. And so it can turn into this air pollution that's almost as bad as what you get in California.
Not that bad.
Yeah, it's the type of.
How about Beijing?
No, we're not anywhere near that, luckily. So,
I guess it depends on how close to the volcano you are. It
Yeah.
can get very bad.
Yeah.
But luckily, not here on Oahu.
So you said that the particles were worse than the SO2. SO2? Did I say that
SO2,
right?
yeah.
Why? What do the particles do to you biologically?
The particles get deeper down into your lungs, and so then they can, I believe they start causing like some scarring in your lungs, and so.
This is permanent.
It's permanent, but I believe the lungs have a bit of ability to repair itself. But
recover.
If you have long-term exposure to it, say if you lived right around the volcano, then you're going to be facing some long-term consequences.
Okay, I
of
think
it.
you can make a case that this is not something we want.
No.
This is a tourist state.
Yeah.
We're supposed to have splendid vistas and clear air.
Right.
And this runs, and I think a lot of people treat VOG as that's just VOG. It's okay. It's part of the deal, part of the environment here in Hawaii. But that's not really the right thing. It's caustic.
It's caustic.
It's
yeah.
not good for you.
Yeah. Try telling the farmers in downwind of the volcano that it's not that bad, because they
Downwind would be what direction?
to the south. So
Pahala.
yeah.
In the
Yeah,
Ka'u.
Pahala.
Ka'u.
Yeah,
The
all
Ka'u
through there.
district.
Yeah.
Because as we said, it eventually oxidizes into sulfuric acid. So they were having to replace their metal fences like every 3 or 4 years, just because it was corroding, and then cattle were just roaming all over.
It's not rust, it's corrosion.
It's corrosion.
It's worse than rust.
Yeah, it's eating away at it.
Yeah.
So
And what about crops? Does it affect crops?
it does. The pH of rainwater around a volcano is pretty acidic, but I don't know how
There-
bad it is anymore.
There were some protea farmers downwind of the vents that had to close up shop. They were affected pretty severely,
Personally or the crops?
the crops. And protea are these beautiful flowers that come from
Sure.
South Africa.
Yes.
The VOG kind of travels around South Point, and then a sea breeze circulation brings it back up onto the slopes on the Kona coast, kind of in the coffee plantation side.
So the coffee is exposed.
The coffee is exposed. It's not clear to me exactly, how negative of an effect that is. That the rain is more acid, and you would think it can't be helpful. Also, the particulates cause the amount of cloud water to be distributed over more droplets, which means that it's harder to get rain out because you have more smaller droplets, and they have a harder time getting together and forming a raindrop. So there has been some speculation that the rainfall on the Kona coast is affected, but there have been no definitive studies of it to date, to my knowledge. And I think that would be a very interesting topic. So
Yes.
if there's any students out there that want to study,
Look right at that camera. And
yeah, any students out there that want to study the effect of fog on rainfall on the Kona coast, that I think would be very, very interesting.
That's Stephen Businger,
Businger.
a professor at SOWEST, and Andre Pattantyus,
Yep.
okay, a PhD candidate at SOWEST. This is ThinkTech Talks. We're talking about fog measurement and prediction here on the SOWEST Hour. We'll take a little break. We'll be right back. Aloha, I'm Jay Fidell. This is ThinkTech Hawaii, broadcasting live from the Pioneer Plaza in downtown Honolulu. We raise public awareness about tech, energy, and globalism in Hawaii. Technology is critical to our state. A vibrant tech sector will give us new prospects in the global marketplace and will offer great careers and make our economy more resilient. Streaming live on Ustream and Spreaker, ThinkTech allows its hosts and guests invaluable opportunities to report important events and discuss important questions, and to be heard here in Hawaii and around the world. You can find links to our live streams on thinktechhawaii.com or on our mobile website, m.thinktechhawaii.com. And you can see our archive on YouTube. It's all just a click away. We want to do whatever we can to keep Hawaii relevant, connected, and thriving in the complexity of the 21st century. We hope you will help us in those efforts. Tune in today. This is ThinkTech. I'm Jay Fidell. Mahalo. Okay, we're back. We're live. We're here on ThinkTech Talks. I'm Jay Fidell on a Monday. And this is the SOWEST Hour, the School of Ocean, Earth Science, and Technology at UH Manoa. And we're talking with Stephen Businger, professor, and Andre Pattantyus, PhD candidate from SOWEST, about fog measurement and prediction. And it's really interesting. So you talk about rainfall, I always think about climate change. And SOWEST certainly is looking at climate change. No one as much as SOWEST, actually. And, you know, sometimes I think that we all ought to go down and talk to the city council and tell them to start doing stuff about climate change, but that hasn't happened yet. It will.
Well, they are fairly proactive in this state. I think better than some states.
Yeah, that's true.
I think that our dependence upon bringing all our goods here and so forth makes us a little more aware, in a sense, that we live on an island and that we have to be thinking about sustainability and growing things locally.
Yeah, Chip Fletcher has been at this table a number of times talking about climate change. And he's active in that area. But I'm reminded of Mayor Bloomberg in New York. Before he left office, you know the story. He said, well, we're having climate change, so what do? You prepare. And so he organized all these big, giant public works projects, to protect Manhattan, especially lower Manhattan, from sea level rise. And those presumably are going on now. So I say to myself, well, you know, Hawaii could do that. We could pour some concrete too. We could protect the beaches. We could protect the peripheral roadways and all that. We haven't gotten to that yet, but hopefully we will. You have to keep on pounding on them.
Yeah, it's an expensive proposition.
Yes, it is.
Yeah.
Nobody wants to spend the money.
It's easier to drive an electric car or ride a bicycle and try to forestall this warming of the atmosphere. But
we have our challenges in that department too, though.
Yeah.
yeah.
So do you think that ultimately there might be an intersection between the rainfall effect you were describing before the break and the, you know, sort of redistribution of rainfall that is likely to happen when climate change gets worse?
Well, that's a difficult question to answer, Jay, to be honest, because one of the areas that global climate models are weakest at, it is in predicting the local distribution of precipitation in the future. So I think that the answer is probably still out there.
We'll know as we get closer.
Yeah, unfortunately. Yeah.
Ask me in 10 years what.
But this kind of examination, though, suggests to me that SOWEST will be there. You will make models on the redistribution of the rainfall, the changes in that way, and you'll be able to integrate those models with all the other models and come up with some pretty sophisticated results as we get closer.
Right. Yeah. They're continually evaluating these global models to see if we're getting improvement in them, and so the hope is that some of these projects will finally pinpoint at the weaknesses and come up with a solution to it to fix that deficiency.
Okay, well, I think we've established so far that that VOG is bad for you. And the question, and I think I know the answer, the question is, can we do anything about stopping VOG? I mean, we go there with some sort of big fan and blow it offshore. Is there anything that we know of that will, de-acidify, make it less dangerous, stop it where it starts? Anything that we can do to stop VOG?
I think that is a pie in the sky idea. They have thought about doing the same for hurricanes. Just, do a little cloud seeding in the right spot and maybe get the hurricane to move in a different direction and avoid a big city, for example. It turns out that the forces of Mother Nature in this case are just too large, short of trying to dome it off, and then it just doesn't seem feasible to me.
Yeah. They have gotten proposals at the park to dome it off, but
Well, how do you think we could ever dome off
no,
the caldera there?
I don't think that would ever be a good idea. I mean, they still get explosive eruptions every once in a while,
Sure,
where
the dome goes.
exactly. So yeah, how long is that going to last?
Yeah.
So
we're left then with trying to protect people from the effects of VOG in other ways, and that's what you guys are doing.
yeah,
Yeah.
exactly.
If you can mitigate and give people guidance for short-term exposure, and you can develop a climatology which tells people, where is it best for me to buy a house, given that I'm really susceptible to VOG?
Yeah.
Is it better to buy in Hilo or in Kona? We can answer those questions.
That's really interesting, because they have automated appraisal now.
Right.
We've talked to the people who do that nationally. They get all the public records and mix them up, and they can tell you what your house is worth without even actually going to look at it. We live in a highly high-tech time. But I suppose this would be a feature that would go to the value of your house. If you were, in the plume, so to speak, and it was coming down on you regularly, your house wouldn't be worth as much as if you had predictable clear air.
Well, it's interesting that before in 1983, there was very little VOG coming out. And it is quite possible that the volcano could have another quiet period.
Well, there's a thing to predict.
Right. I'm not suggesting that that's in the wind, that it's going to stop.
You mean that as a pun, right?
Sorry about that. Yes. So, I know that people tell me that live in Kona and have lived there since the 70s, that it was beautifully clear there, and now it's pretty foggy. The visibility is definitely impacted.
Why? Why is it more? I mean, is it just the way it is? It's just the way of the world, the way of nature. It's Mother Nature speaking, or is there some process that we can get our hands on to explain why it's more foggy now than it used to be?
Well, it has to do with the emission. We have two vents, Bulu O'o and the Hali Mau Mau vents, that are both very active at the moment, producing hundreds of tons of emission of sulfur dioxide a day. So it's a lot of pollution.
So could we predict, for example, that in 5 years it's going to subside?
They're working on that.
I never promised you a rose garden.
There's a relationship between the emission and how much seismic activity there is, how many earthquakes there are. Conceivably, if the seismic activity quiets down and the motion of the lava goes elsewhere, because in time, our plate is shifting and there is a new volcano that's developing under the ocean, it could get quiet. On the other hand, Mauna Loa has the potential to erupt still, and the last time we had a big summit eruption on Mauna Loa was around 1950. And that can produce a tremendous amount of gaseous emissions. So the problem could get worse rather than better. It's just hard to predict.
Interesting. Is this the kind of stuff that Don Thomas follows?
I'm sure it is. Yeah,
Interesting.
yeah, and James Foster, a colleague of mine in SOEST, he has a number of GPS sensors that very carefully measure the motion of the Earth, and also tilt meters to measure the tilt of the slope, and they're looking at Mauna Loa very carefully to try to predict when it might erupt again.
So, I mean, your work assumes the continuation of the smog effect. If there were no emissions,
That's right. Then we start looking at something different.
something different.
Yeah.
But it's very easy to generalize our work because, for example, coal-fired power plants produce a lot of sulfur dioxide. And so the chemistry model
Yes.
that Andre is working on will be
Yes.
equally applicable to that type of a situation. China is opening lots of new coal-fired power plants, and we have them in the US as well. We can do the dispersion modeling
Yeah.
for them.
Yeah, this is very, so what you're doing now could have huge effect later. And I think you'll always have a job, actually, Andre.
I hope so. Yeah.
Pollution will be a problem for a while.
Yeah.
Yeah, those plants in China, and they're very concerned about it, too. Anyway, so I wanted to get into, take one more break, but I wanted to get into this whole question of exactly how you model the movement of the plumes. What the sensors are, what the technology is, what tools you're using to do that, and of course what software, and I know there are a lot of acronyms. You can help me with the acronyms. We'll take one short break and come back to that. This is ThinkTech Talks on the SOEST Hour, talking about VOG measurement and prediction with Stephen Businger and Andre Pattantyus of SOEST. We'll be right back.
Hi, my name is Dr. Rafi. Every week, I'm right here at ThinkTech Hawaii, 3 p.m. on Mondays. My show is Boards' Bio Briefings. What do we do here? Well, we watch sperm swim, we see if they catch anybody, we check out the latest biosimilars, you know, the kind that, what was his name, the guy with the bicycle? I guess we forgot his name, but he was taking EPO and other human growth factors. We'll be talking about human growth factors. You want to know where to get some? Maybe I'll tell. Anyway, you can catch me, as I said, every week right here, Monday, 3 p.m., ThinkTech Hawaii, Dr. Rafi. You can also find me on Twitter, BioInfo Medical. Or you can catch me on Facebook, Dr. Rafael Boritzer. I'll be happy to converse with you. Aloha.
Okay, we're back. We're live. We're ThinkTech Talks on the SOEST Hour, talking about VOG with Stephen Businger and Andre Pattantyus, both of the SOEST. And I guess we'll talk now about the exact science of measurement. So let's turn to you first, Stephen. What tools are you using? What software are you using to, for example, get the data on the weather?
Okay, so the fact that Hawaii is an island state in the middle of the Pacific, 2,500 miles from the nearest large landmass, means that we have to rely a lot on satellite data in order to feed our weather models with information that the weather model needs. And one of the things that SOEST has helped one of the capabilities that SOEST has helped purchase recently is a satellite downlink for data from polar orbiting satellites. They pass Hawaii twice a day, and there are maybe a dozen different satellites, and they have very high resolution sensors. They can see very clearly in the atmosphere.
They're looking down on Earth.
And they're looking right down on us. But in order to get those data, you have to have this downlink right here in Hawaii, because otherwise, in order to get the data from elsewhere, from another downlink, it would no longer be current. It would be old data, and then it can't be used in a weather model because weather data is perishable. You have to have it in real time in order for it to be useful.
So with the downlink right here, it's almost like a mirror, because what the satellite sees, you see
Exactly.
pretty quick.
Yes.
Yeah.
Well, that's fabulous. You know, and also it opens something that I didn't know, and that is you say there are dozens of satellites up there. Are they all available to you? I mean, is this data free? Can I just link up to it and get everything that's floating around like that?
The data are free, and we post them on the web, so that you can actually go look at these data. The website is weather.hawaii.edu, and we also have the VOG model results posted there as well. So back to the question of how the data go into the weather model, we use a model called the Weather Research and Forecasting Model, and we have an acronym WRF, which is pronounced WRF. So we run the WRF model.
Nicely done.
Yeah, and it's a model that is actually developed by a consortium of universities, and they are sort of coordinated, if you will, by the National Center for Atmospheric Research. So it's a big enterprise to get these weather models to be as sophisticated as possible.
These are national or international?
It's used internationally. Yeah, it's also used by the National Weather Service. So it's a regional model, and it's very high resolution. And the reason that that's important in Hawaii, as we know, is because we have such big mountains and lots of terrain, big effects of the terrain on the weather, and that has to be simulated in the model. So you need to have a very high resolution model to get all the cloud interaction and wind interaction with the mountains.
So when I get the report, I get the data down, and I'm making my weather model, what does it look like? A spreadsheet? Some database with zillions of fields and, zillions of records? What does it look like?
That's an excellent question, Jay. and certainly those data are out there. They're in the computer, and if you want, you can really look right down at the numbers. But to make it more, consumable by the scientists, we have to turn it into maps that we can read. And so we have maps that show temperature, maps that show the winds, maps for relative humidity. All these different fields are shown, and they're shown at different levels in the atmosphere as well.
So you need software that will interpret that data in those spreadsheets into a graphic representation.
Exactly.
You have one with you? You had something like that on your computer. Maybe you could show us what the graphic representation looks like.
Okay. This is an output of the VOG model. It's actually showing the distribution of the emission from the dispersion model. So it's not exactly weather, but the weather model was used to provide the winds that drive this. And it turns out that in this particular animation, it shows Hurricane Flossie's wind field interacting with the plume and causing the plume to spiral and produce that nice.
So this is the bottom line. You've taken the weather model, you put it in here. You've taken Andre's dispersion model, put it in here, and something on there. I don't know what. Some color is going to represent the plume.
It's the concentration, yeah.
What color is it that we?
So we have there's a color table in here, and so these are levels that are defined by the EPA. These are EPA guidelines for exposure levels, and so the green is the lowest level where they consider it good, but if you have acute problems, then you're gonna feel it, and then it goes all the way up to purple where it's hazardous is their definition for it. And so the model shows that the concentrations are pretty high right near the volcano where it comes out, and then it just kind of gets
dispersed.
It gets dispersed, yeah. It gets
So
spread out.
I don't know if our viewers can see that on the screen, but this is a map of the islands of Hawaii.
Yes.
And it looks like you're replaying one scenario.
Yeah, it's looping through.
And you're
yeah.
taking a lot of time and making it
Sure,
and making it much more quick.
Right.
And you're showing 4 or 5 seconds actually of something. What is that? What is
Right.
was
So,
that like
so this
one
is
day?
So we're looking at I believe this is a 48-hour.
48 hours.
So, yeah. So it's starting on the I believe on the 28th of July of last summer when Tropical Storm Flossie was approaching the islands of Hawaii, and then it goes right through until where right at the end where it kind of starts disintegrating. The storm starts disintegrating.
So so the storm is taking
The storm is wrapping the emissions into its own circulation.
Yeah.
So you start seeing what looks like a tropical cyclone because there is a tropical
turning,
cyclone.
right.
Yeah, and so it's wrapping it all around. Yeah, and
Now,
so this was an interesting case that we saw last summer, and we studied a little further.
So what I see is red, which I guess is the most caustic and
Yeah, it's pretty
dangerous
high.
emissions, not antigen type emissions. I guess they all are.
Yeah.
And it seems to be heading out in wider swirls.
Right.
And it doesn't look like it's crossing over any of the other islands in this one case.
Right. Yeah. We made out pretty lucky with this case because the track of the storm kind of went around the islands, and so that was good for regular storm damage as well. Where it didn't really make landfall anywhere, and so it also didn't really bring in the emissions either.
Yeah.
So
So in this case, for example, Oahu didn't, as I look at it, Oahu did not have the red color of emissions
no.
floating over the city of Honolulu.
No. Yeah.
But it could.
It could happen in the future, yeah, if we get another case like this.
Yeah.
So this is just kind of illustrating that, this type of thing does happen, although
Yeah.
I believe this is the first time we ever captured something like this.
That's pretty interesting. So now I wanted to get to the dispersion model,
Sure.
which is built into what Stephen has shown us here.
Sure, yeah.
How do you do the dispersion model? And I heard the word sensor in here somewhere. We here at ThinkTech are always interested in sensors. We love sensors. We love cheap little sensors that,
Yeah.
that can be redundant and read enormous amounts of data.
Sure.
So what are you using?
So we get measurements from the volcano, from Volcano Park that actually Keith Horton developed. So it looks up at the plumes in the ultraviolet spectrum, and so and then it calculates how much light is getting taken out of the field of view, and so that gives you an idea of how much is being absorbed, and you can estimate the amount of emissions that are in that swath.
How does a sensor do all that? I've heard of lasers doing that kind of thing, but what kind of sensor is this?
It's
It's a light sensor.
it's a light sensor.
So it's reading light waves.
Yeah, so it's looking at how much light is being detected in its field of view, and so if there's not that much light being detected, then you know that the plume is right over you, and you can estimate a concentration.
So you have to put on your boots and go out into the terrain and put sensors out there.
Yeah, so there's an array of sensors that are out in the Kao Desert out there in Volcano Park that measure this. But then the wind doesn't always blow towards them, so there's a couple of them are mounted on cars that volunteers
Mobile.
they're mobile. So volunteers at the Volcano National Park actually drive around the roads to try to capture where the plume is.
But you know where the car is.
Yeah.
It's
So everything's
GPS.
Everything's geolocated. Yeah. So we
Yeah.
know exactly where everything is. Yep.
How big are they? Should my
I
wife
believe-
give me one for Christmas?
Yeah, I believe they're about this big. You'd have to talk to Keith about the price, but
You mean it would be expensive?
yeah, I imagine they're pretty expensive.
About $25,000, I believe, for one of these.
Yeah.
So they're not cheap. But there are a couple of dozen volcanoes around the Pacific that have these sensors installed.
Yeah.
So he's a popular guy.
Now tell us about Keith.
Well, he's really an engineer,
Mhm.
and he has put together this spectrometer. It's really
What's his last name?
Keith Horton.
Horton.
Yeah, okay. He was supposed to be here with us.
Yeah.
Yeah, I was supposed to be here. He felt that he had to study too hard in order to answer your questions. But really, I think it was a family issue.
Yeah.
They couldn't make it.
Okay, well, so he's the one who would know about the sensors and the technicals on the sensors.
Yeah. Yeah.
So now I have my my weather data. I have my dispersion model based in large part, I guess, on the sensors.
Yep.
And I can make that kind of swirly movie that you showed us.
Sure.
So I know, say, in a 48-hour period, what's going to happen with a storm or anything, in any
Right,
weather. I
right.
can tell where these VOG fumes are going to be distributed. What do I do with that information? This is perfect, for the last part of our show to discuss this, right?
Sure.
So I have all this information. I have that movie, that very impressive movie. What do I do with it in order to achieve the purpose of the research?
Well, the purpose of our research is so the model puts out forecasted estimates of where we think the plume is going to go, and so how high the pollution levels are actually going to be. And so there's actually Department of Health sensors around all the islands that actually measure these values continuously. So
You have access to that too?
we have access to this information.
That's
yeah,
great.
yeah. And so they send us that information so we can compare it right against the model to see how well the model is actually validating against the observations.
So it's a control. It's a
Yeah,
validation.
it's a check. Yeah, it's a check to see that the model is doing well. But for the general public, our animations are available online, so you can get an idea of day to day if you're going to be exposed to high levels or levels at all.
What's the online, what's the address? Do you know?
It's weather.hawaii.edu.
Oh,
Right.
okay, that's out of SOEST. Yeah.
Correct.
Yes.
And the observations are also online.
Yeah.
Okay, so I'm looking at this, and I say, whoa, looks like it's going to go over my neighborhood. I can see that, yeah, because there's a map underlay.
Right.
What can I do? What can I do now that I know that the most dangerous part of the plume is over my house? What can I do?
Well, you can close your windows, turn on your air conditioner, and just stay indoors.
Yeah.
If you're really affected by it. And so,
Yeah.
some people are very allergic to this, and they have a bad reaction. And so they can just avoid it. And you can breathe through a mask. And
Some people do that, sure,
Yeah.
because they're on the verge of having breathing problems anyway.
Yeah.
Right,
This will
right.
exacerbate their breathing
Yeah.
problem.
Yeah.
But what about the question of degree? In other words, if it's just a little red, that's not as dangerous for most people as a deep red on the map.
Right.
So can they tell? They can see the same map that you showed us here today?
Yeah. Yeah.
And they can tell how deep the red is,
Sure.
and thus how dangerous it is.
Right. Yeah. So you just have to make the best judgment. And I mean, if you're gonna be going out for a run, and it's maybe an orange color, that you might feel okay during the beginning of your run, but maybe at the end of your run when you're tired, it might start affecting you. So you just kind of have to take all things into consideration.
What about the media? I mean, it seems like if you ask people to go to this weather site, they may or may not know about it or go there. They may not know enough to go there.
Yeah.
How do you push that information on the community?
Well, some of the television news programs have picked up on the model output, and we give them access so that they can put the animation on television, and they've been doing that.
So you send them an animation and give them
Right.
a warning, and then they play it.
Yeah.
And presumably then the public has a better access to it.
Right. Yeah. And the TV weather people are in tune enough to know that when we get southeasterly flow, and they can see that on the weather chart, that the likelihood of a VOG episode rises, and so they then access the information from our model. And it turns out that between about, I would say November and March are the months where we're most likely to see these southeasterly winds that'll affect Oahu. So
November and
winter
March. So
time.
that'd be the non-trade
The non-trade, exactly.
time of
Yeah,
year.
Hawaii is fortunate to have prevailing trade winds most of the time, and during the summer, the VOG problem is pretty minimal on the outer islands. It's mostly confined to the Big Island and Pahala and the Kona coast during the summertime. And we don't see it because we have northeast trades that keep us in the clear.
So are you building the trades? Of course you're building the trades into your dispersion model or
Correct.
weather model?
Right.
Both.
Both.
Yeah.
Yeah.
And that would have a big effect because that could disperse them really quickly
Or it just blows it away from us here on
anywhere
Oahu.
else.
Yeah.
So not to belittle the folks in Kona who have more of an issue,
Yeah.
but at least we'll be in the clear.
Well, one thing you touched on, which I'd like to pursue in the last couple of minutes of our discussion, is how the lessons that you've learned on building the weather patterns, getting the data, building the weather patterns as an element of how the plumes will be dispersed, and then creating the dispersion models over the other data you have. That's really interesting, and query. That could be used for lots of other things in lots of other places. Not just coal smoke in China, but any kind of disbursement of noxious material in the air, anything like that.
And how it evolves. I mean, that's
Yeah.
the crux of his PhD research, is to say, okay, at the vent we have mostly sulfur dioxide, and downwind a ways, that sulfur dioxide gets changed to sulfate aerosol. That process of evolution from sulfur dioxide to sulfate aerosol is complicated and difficult to simulate. But if we can get it into the dispersion model, it'll be a big step.
Let's see where it's going to go.
And then we will do much better in terms of having our model output match the observations, because now we have the physics in there, the chemistry in there to allow it to match. So that's where we're headed.
So let's look at Fukushima for a minute.
Yeah.
That there was noxious radioactive particles
Yeah.
up in the air from that as well as in the water. Could your modeling, could what you've learned on VOG be used to find out where that was going to go and to make a weather dispersion pattern to show what areas were in jeopardy?
Well, it's interesting that you would ask that. It's almost as though I planted that question, because I just had a PhD student graduate, and his thesis was the dispersion of the nuclear fallout from the Fukushima plant. So
you can do it.
yes, absolutely, yes. He used a slightly different approach. He had the dispersion model built within the weather model. But it's basically, the same.
The result is the same.
The same type of research. Right?
So a meltdown like that, a Chernobyl kind of event, it'll happen again. There are reactors all over the world one way or another.
Let's hope
or
not.
concealed explosions one way, and you don't want to be downwind of them. So this is the ultimate downwind test.
And think of volcanic eruptions affecting flights in Europe from Iceland. That's also a dispersion model problem. And they were actually grounding planes, depending on what the dispersion model was showing as to where this plume of, it's more a silica type ash rather than the VOG that we get. So it's a different phenomenon, but the science of dispersion is the same. And so,
Well, where are we on the continuum of the science of dispersion? I mean, this whole science you're talking about here today about VOG. It seems like to me there's, it may be a decade or two old, but it's still in its infancy and there's a lot to learn. Am I right about that? How do you feel about that?
well, I hope there's still a lot to learn.
Touche.
Turbulence is a problem which has not been solved. And I don't know if we ever will be able to solve it. So I think that we can always make incremental steps to improving our dispersion models. And I think that in the case of VOG, getting this chemistry properly into the model is a really fun and important step.
Yeah, to help us understand our universe and how it interacts with us. It's very interesting, and it sounds to me like it has applications in the future. And as these things change, or as and when they change, in terms of climate change or anything else that might change the weather, you can build that in, so you can deal dynamically with the way things go on this planet.
Exactly. It'll be ready to handle those kind of changes.
Yeah, great.
Yeah.
Good work.
Yeah.
Thank you. Thank you, Andre Pattantyus and Steve Businger. When do I get it? ThinkTech Talks, the SOWEST Hour, talking about VOG measurement and prediction. Hope you guys can come back, later on when you learn more and talk about how the project goes and its further applicability, and especially after a particularly large emission, we'd like to talk to you again.
We'd be happy to come in. Thank you
Thank you,
for
Steve.
inviting
Thank
us.
you. Yeah.
Thank you, Andre. Aloha. This is the SOWEST Hour, and we'll be back in a few minutes with Ehana Kako, where we're talking by Skype with Wayne Hoffman of the Idaho Freedom Foundation and Kali'i Akina, who is also going to be in connection by Skype. Aloha.